Only Ankush knows these answers. Yeah, it is programmable logic controller. No, Hitesh, it is programmable logic controller, not pulse logic controller. Again, my question to you is that what is the difference between your microprocessor and microcontroller? I think you might be knowing about that. What is the difference, or you can say what are the pros of microprocessor over microcontroller? Can you tell that? What are the advantage of microprocessor over microcontroller? Use of external bus, yes. And what about memory, expandable memory? Who has the option of expandable memory? Microprocessor or microcontroller? Okay, so Khushbu is saying that microcontroller has a facility. So microprocessor only a CPU on a single chip, while controller has internal controlling bus and several components linked on single chip. Okay, okay. So my next question, kindly answer these questions, because why it is important is that throughout cleared that a little bit about a microprocessor and microcontroller also. We will deal with that also, and how PLC is related to it. So PLC, can you say that PLC has embedded microprocessor or microcontroller? Programmable logic controller has embedded microprocessor or microcontroller? My question is this. All should answer this question. Alok had answered it. Yes, correct. Logic controller then. If it is programmable logic controller, why we, and it has an embedded. Can anyone answer this question? Why is it called programmable logic controller when there is a microprocessor embedded to it? Okay, we'll have all these answers in this session. Okay, all these questions related to PLC will be answered to you. Okay, so now let us begin with PLC. Today we are not going to deal with much more you can say videos, because videos are not available and most of the videos are not so much informative. So we are going to just start with our PLC and basic logics. Okay, so just kindly respond that whether my screen is visible to you, yes or no. Now is it visible? Yes. Okay. So Again, this session is for you to answer this particular question within yourself. Okay, no need to write it on the chat box or reply it to me. Just answer to yourself that what is PLC. So answer to this question is that it is a programmable logic controller. Yes. And PLC is an electronic device equipment which we have already read this, that we can have pneumatic control also, we can have relay control also, but that is hardwired relay control, or pneumatic control is very much bulky. Okay, so our compact solution to that control system is PLC. Okay, so this is the difference between your processor and controller. Your laptops have and mobiles have processor, right? And your controllers are mostly based on Arduino or Raspberry Pi, right? Your processor have flexible memory. Your controller have fixed memory. Your processor can have flexible IOs, so your input and output can be flexible, okay? And controllers have normally fixed IOs, okay? Even if it is not fixed, you can extend, but you need an external supply for that. But you don't need any external supply required for IOs, okay? Apart from that, you can say that processor can do multitasking. It is a parallel data type, okay? Whereas controller is your serial data type, and it is a single tasking. So it works on a serial manner, okay? So if one data comes, it get processed and it gives an output. Whereas in parallel data, various data can be stacked and can be processed. Where does the PLC lies? The PLC has an embedded processor, okay, but the data input is in serial in nature. Okay, so just understand this, that how PLC is different. So let me just use a duplicate slide and just let me escape. Yeah, let me just use a duplicate slide, delete this, and yes, start with. Okay, so we have a special kind of memory, you can say cards, or you can say special type of memory embedded in PLC, which is called your PII and PIQ. We will discuss about it in detail later. So suppose this is your PII. PII. Okay. This is your IO module. Okay, we are just looking at the structure of your PLC. Okay, this is your input output module from where your sensors, or you can say any kind of input, is connected. Yeah. Any kind of input is connected. Say 3 kind of input are connected to your IO module. Now this IO module is connected or is in communication with your PII. Then you have your CPU. Then you have your CPU, which have a load memory where your programs are loaded. And it is also in a continuous communication with your PII. Okay. Now you have a PIQ. PIQ. And now this is connected to your this is an input module. Let us say it is IM. Okay, so this is your input module, this is your PII, this is your CPU, this is your load, this is your PIQ. Okay, and this is your output module. Just have a very brief look at here and just kindly focus on this. So that data, okay, so your CPU has a sort of arrangement of parallel processing. This your CPU is an embedded micro, you can say, processor which has parallel processing, but your data comes in a serial manner. Okay, so what happens is that your data is coming in a serial manner. Okay, your data comes in a serial manner. Although your data comes in a serial manner, your PII, which is a special kind of memory, what it does is that it stacks your serial data. Okay, it stacks your serial data. Okay, you can say it can stack with a proper. When CPU calls for this particular data, it provides that particular data to CPU. CPU completes its load cycle, or you can say your code cycle, okay, scan cycle, and provides an output to your PIQ. And PIQ will get a stacked output for that. Now your PIQ, okay, your PIQ will give your output module communication to start your actuator or any kind of actuation. Okay, so you can say that this is machine M1, this is machine M2. Just I am repeating it one by one. Your serial data, your data which is serial in nature, comes to your input module. Your PII stacks this particular data, okay? And whenever CPU calls for this particular data, it provides that particular data to CPU. CPU completes its scan cycle and provides an output according to a logic. Now your load memory will contain the program that will convert this input into a stack of output, and that output is collected at PIQ. And that stack with a proper address is provided to output module, and from output module you can run a particular machine. Now say for example, the what is the, you can say, scan cycle, how much time does it takes for a scan to complete? Can anyone tell me? Kindly unmute yourself and answer. Anyone? Okay, what is the, you can say, processing speed for your PLCs? Is it in megahertz or is it in gigahertz for PLC? Okay, I'll just look into the answers later. For now, you need to understand that it is in microseconds only, okay? Or you can say some sort of milliseconds, because the hertz or the speed is in megahertz, okay? One cycle can be completed in megahertz and it will be ready for another cycle. But what if your machine 1 has to be run for, say, 20 seconds? Then what will happen? So for example, you have a memory load, okay? So PIQ will give this particular instruction, and a separate memory will be addressed for this particular machine, that yes, it is running, and until and unless it is not completed, we are not going to start the next process in this. Okay, so that memory is embedded excuse me, in PIQ. which is your card, this is your output card, and this is your input module, this is your output module, this is your CPU. Okay, so we have a facility of providing a memory which is a kind of volatile memory, okay, which will provide that particular timing, and it will not any execution of cycle until and unless this 20-minute cycle is complete, 20-second cycle is completed. Let me just repeat it again for you. So your serial data will come into your input module. Okay, this will be stacked in your PII. Okay, then they are in communication with CPU. Whenever CPU requires a particular input, it will call it from PII. It will process it in the load memory. Okay, it can parallelly process many kind of memories. Okay, many kind of data from PII. Okay, then it will provide an output. It will provide an output to PIQ. Okay, so PIQ will communicate with OM, and it will communicate that whether machine is free or not, machine 1 or actuator 1 is working or not. If it is working, it will not run that particular cycle. If it is not working, it will execute the program. Okay, so this is all about the very basic working of a particular PLC as far as processor and controllers are concerned. Any queries regarding this class? So, yeah, microprocessors are have the speed of gigahertz. Okay, but your PLCs have a speed of megahertz because of PII and PIQ associated to it. Okay. Any kind of doubt? Were you knowing it earlier? My question. Let me switch this question. Were you aware of this fact? No. No. Okay. So if you understood, we are again going to do that particular exercise that you need to just draw this. I have drawn it, but just so that you can memorize it, there are many things inside it which will be dealt by Mr. Suraj, but let us be compliant enough that we know what is the structure of PLC. So just draw the structure, whatever I have told you, and respond it on the WhatsApp. Okay, whatever I have told you. Again, I am repeating, the single stack of data, or you can say serial stack of data, will be provided to your input module, and from input module you are going to get direct communication with your PII. Then from PII you are going to get communication with CPU, which has a load memory where it will process it. Okay, after that from CPU you will communicate with PIQ. Okay, and in PIQ, after PIQ you will communicate with output module, and after output module what you are going to communicate with, you are going to communicate with machines. So this is the particular cycle that I was talking about. Just draw it and respond on kindly respond on WhatsApp. Okay. Yeah, input module, Hitesh, correct, through PII, then CPU, PIQ, you have Output module. Okay. Okay, correct. Yes. Correct, Hitesh, you are correct. Abhay also is correct. Ritik, input module, then PII, then CPU, load, memory, PHQ, PIQ, yes, and OM. And OMs are connected to machines. Yes, correct. Yes, Muskan, you are correct. Yes, Shubham, you are also correct. Nayan, you are also correct. Yeah. Yeah. So most of you are aligned to it. Okay. So what are all components of PLC? Let us look into that. We have already learned that what was the basic structure of PLC, how PLC works. Now, one more thing, you can see that although it has a microprocessor embedded in a controller, why it is a controller? Because the data that is coming to it is in a form of serial data. Okay, but because of the presence of PII and PIQ, what we have is, yeah, because of the presence of PII and PIQ, what we have is that we have a capability that we can stack that particular data and can provide it to our processor in a parallel form. Okay, so these are our constituents of PLC. We will have a power module also. Yes, Aparajita, you are correct. Sunidhi, you are also correct. PII, CPU, load memory, PIQ. Yes, you are correct. Kush, yes, you are also correct. Yeah, so most of you are aligned now. Okay, yeah. So now let us look at the constituents. So you will have a power module which will power your PLC. You will have a CPU, central processing unit. You will have a memory unit. You will have input and output module, and you will have programming device. Now this programming device is a very dedicated mechanism or you can say machine which has specific type of platforms of TIA, which is a Siemens platform, and similarly we can have different type of platform for different type of PLCs. एंड इसकी कॉस्ट केवल एक मतलब लैपटॉप में अगर आप साथ में एम्बेड करके इसको दे रहे हो तो लगभग, और ये एक डेडिकेटेड डिवाइस होता है इतने सारे डिवाइसेस को हैंडल करने के लिए. नॉर्मल लैपटॉप्स विल नॉट बी एबल टू हैंडल इट. ओके, इसकी कॉस्ट भी काफी ज्यादा होती है, लगभग 15-20 लाख का एक छोटा ही प्रोग्रामिंग डिवाइस आता है. ठीक है ना, दैट इज द टाइप ऑफ कॉस्ट दैट इज एसोसिएटेड टू इट. Then why we use PLC? Okay, so we had already aligned ourselves that how difficult a manual control is. Okay, so all the operations, actions required to control the process, you know that how much tough it is, that for an even for an very simple you can say operation of controlling the temperature, this operator has to be present at the hand valve continuously in order to monitor the pressure. Okay, if we are able to monitor automate it, then we can have a higher productivity in industries, we can have higher output, we can lower the cost, and we have many pros associated with that. Although if we are using a hardwired logic control, we all know that hardwire logic control, this is a what kind of control you can say? This control is based on what kind of control is this? Can anyone tell me? These are what? This hardwired control. Apart from that pneumatic control, we can also get a control through. We have covered it in the previous session also, class. Kindly respond. This is the kind of, what kind of control is this? Electric, electrical switching. What type of device did we involved in this? Nayan, you are correct. Yes. Yeah. So this is your relay logic control. So this is your relay logic control. Okay. Now you can see that even this is a very simple controlling analogy. You can see how much complex it can be when we use a very simple relay logic. Just let me, yeah. So this was considered to be the first step towards automation when we had contactors and relays together with some kind of output timers and counters which were used in achieving the desired level of automation. But you can see what kind of complexity it has induced into the system. Okay, and we understand that how much complex a process can go. A very simple process can be very much complex in nature, and in order to control it we can have a very complex you can say uh, as far as relay logic is concerned, it will be very bulky in size and it will be hard to find faults and troubleshoot. Also more power consumption will be required for this. Okay, now then we had electronic control. The solution to this was electronic control. So with the advent of electronics, the logic gates and further microprocessor or microcontrollers started replacing the relays, and auxiliary contactors came into control cell. Okay, the timers are replaced by electronic timers now. You have embedded timers into your PLC. Okay, and you have embedded softwares or platforms where you can have these timers, and we don't require a timer separately for a particular system, or even a relay logic, or even a latching logic. Okay, due to this we got the digital control, and the size of control system turned compact. It replaced the complex wiring by integrated circuits and operated on DC voltage. There is only one drawback with this control system, that it is programmed and it is difficult to reprogram or can't be reprogrammable. But that was for your electronic control, that was based on your microprocessor or microcontroller. This type of electronic control first came through microcontroller or microprocessor. Kindly respond, class, please. Yeah, microcontroller based. Okay, so these, yeah, so I think Ritik has worked on microcontroller projects, but now we have a system that we can change the program in a particular microcontroller. But once we embed it or download it and we provide a separate chip for this, then it is tough in a microcontroller to reprogram it. Am I correct, Ritik? Yes or no? Ritik, you have worked on microcontrollers, right? Yeah, yeah. So PLC has a very basic kind of logic structure embedded in them, and it is reprogrammable. Okay, so the main benefit for it is that it is reprogrammable. Okay, so now PLC have been in recent years experience, then PLC is going to be there, because it has been infused into the industries in such a manner that irrespective of any domain of your industry, whether it is a pharmaceutical industry, whether it is an automobile industry, whether it is a aerospace industry, you are going to see PLCs there. Okay, so PLCs have been in recent years experienced an unprecedented growth as universal element in industrial automation. So wherever there will be an industrial automation, there will be a PLC there. Okay, it can be effectively used in application. It can be used for simple application. It can be used for complex application. You can use it for factory automation. You can use it for process automation. Okay, you can control a temperature through it. You can control a flow through it. You can control the number of objects passing through a conveyor line through it. You have lot of scope if you know what PLC is. Okay, and every kind of industry welcomes someone who has a very you can say, although very preliminary knowledge about PLC also. Okay, so how to use PLC? So to use PLC, there are dedicated softwares for each PLC for every brand, and it is according to IEC 61131 standard. And according to this standard, we have 3 languages. But what kind of language we are going to consider here is ladder logic, because it is one of the simplest logic that is used, and we have only two here. We have only two access to only two languages. One is ladder logic and functional block diagram. Okay, but we are going to cover ladder logic only. But once you know about ladder logic, you can always convert it into SFCs, structured text, or instruction list. So according to this, and ladder logic is very easy to understand also. It is not a very complex kind of, and it is much more graphical and representable as compared to other languages. Okay, so kindly note this particular standard. I can ask this in your test also, that what kind of standard is used for programming languages. Okay. So first is your ladder logic. You can see that it is just a graphical kind of language which is used to convert relay logic. So we can convert that relay logic into a ladder logic. Okay, so why it is called a ladder logic? Because it looks like a logic which looks like a 2 rungs. Okay, one will be for your, you can say 0, one can be for your 24. Okay, and you can have any kind of logic associated to it. You can have an ANO logic associated to it. You can have a output associated to it. Okay, you will cover all these concepts in details when you will be when the session will be provided by Mr. Suraj from Automation Lab. Don't worry about it. We're just getting a very brief information about what PLC is and how it works in this particular session. Okay, but this is important. Okay, so this is about your ladder logic, your ladder diagram. Here you have sequential function chart, that how a particular sequence can work. So we have how sequence is important. There will always be a particular sequence through which it can work. So we have a sequential function chart through which we can also operate. Okay, then we have functional block diagram. We can convert ladder logic into FBT accordingly. We can have a block representation for each and every logic here. Then we have structured test, a more like a programming language. It is more textual in nature, graphical. Okay, then you have instruction list. Okay, so this and structured text are somewhat equal, but in instruction you will have a very specific instruction and a very compact type of we can say programming language. But the more compact the programming language is, the more difficult it is to assemble it and to interpret it. Okay, then this is the block diagram. Okay, so you can a 220 volt or 120 volt AC supply with any kind of 50 hertz of your supply, okay, which is the standard here, and your power supply is going to convert it into 24 volt. Okay, so your PLC can be powered into 24 volt, or it can have a power supply embedded into a PLC. So you can have a power supply separately also, and also what you can have a power supply embedded into the PLC also. But the basic internal modules work on 24 volt only. Okay, so you can have a AC kind of PLC also and a DC kind of PLC also, but in AC kind of PLC you will have a power supply embedded into the PLC, which will convert it into 24 volt and supply it to the input module or output module. Okay, but your CPU or your programmable memory will be working on 5 volt DC. Okay, so what happens here is, and your output model, this all will be associated with your feedback, input, control, and process of machines. Okay, so your input will be elements. We have already looked at it, that it can provide you a particular outcome. Okay, and your input module can have this particular outcome. Okay, or your output module can give a particular kind of output to your machines or your process, or you can say your actuators. Okay, but important thing for here for us to understand is that how this 24 volt is getting converted into 5 volt. Okay, so what we have here is, do you know what kind of instrument do we have in order to convert this 24 volt into 5 volt DC? So first question arises is that why CPU require 5 volt, why not 24 volt? Ritik, resistances or voltage regulator? No. The answer is no for this. Okay. So do you know what is optocoupler or optical isolator? Okay. So you don't know about optocoupler or optical isolator. Okay. Okay. So what optocoupler or optical isolator does in a PLC is that it is a LED based system. So just let me duplicate a slide. Let me just delete this and this. So when a supply of 24 volt is provided, okay, you will have a kind of LED, okay, and this LED okay, whenever 24 volt is applied, this LED gives on this optical collector, and this collector converts this LED light into a constant voltage of 5 volts, and this is somewhat your optocoupler. Or let us have a quick look that whether we have a video for that or not. And let me just see. I have not searched for this. I thought that you might be knowing about optical coupler. Let us have a look into the options of video. Yeah, optocoupler. So you have a start input signal. In this case, you have a kind of, again, this LED, or you can say, yes, a kind of transmitter LED. So you have a receiver phototransistor. This will provide, on activation, this will provide light infrared beam and it will actuate the receiver. So
an optocoupler is an electronic component that transfers electrical signals between two isolated circuits by using light. Using an optocoupler, when an electrical current is applied to the LED, infrared light is produced and passes through the material inside the optoisolator. The beam travels across a transparent gap and is picked up by the receiver, which converts the modulated light, or IR, back into an electrical signal. Thanks for watching.
So I think now you know what is an optocoupler or optical isolator. Okay. So just tell me that what is the requirement of optocoupler? Why we needed a optocoupler in PLC? Why won't we use a Zener diode? Adarsh, the main purpose was to use a safety device along with it. Main purpose was isolating a particular circuit from other circuit. Okay, and the most physically capable isolator that is available with us is this kind of optocoupler. With Zener diode, yes, we can get a certain degree of safety, but that kind of safety that is required for industrial requirement, that can only be provided. You can physically sense it also, that through rays only it can provide a particular signal. Okay, so if larger amount of rays are going to be impinged on your transistor, then also 5 voltage is only going to be there. It can be done in Zener diode also, but it cannot be controlled to a very it can be controlled only to a limited manner. But for optocoupler, because industrial safety is very much required, isolation of the two circuits is very much needed in industry. That is why we have used optical isolator, or you can say optocoupler, instead of Zener diodes. Yes, Zener diode also functions like this only, but in order to provide a better kind of isolation and a more, you can say, from more safety perspective, we have used optocoupler. Adarsh, is there any doubt apart from this? Okay. So is there any doubt till now? Now you understood what is optocoupler and why we require this kind of optocoupler class? Yeah. So yes. So that is why a PLC is such a rugged kind of, you can say, controller. It can provide you the pros of your processor. It can provide you safety. It can handle data that is coming from sequence, or it is serial in nature. It can provide you parallel tasking or parallel processing also. You can add input and output. The most important factor for industries is that a process is going to be complex. There can be hundred or thousands of sensors, input and output for a particular process, and we don't want many PLCs for each and every kind of process. So we can have a single process. We can add input and output module, although there is a limit to it, but we can add it to a very great extent. Okay, that we will learn that how many input or output module we can add to a particular PLC. That will be taken care by Mr. Suraj. But important thing for you to understand at this point of time is that PLC, why it is so much suitable for industries. First reason, it is very good as far as industrial safety prospect. It can handle parallel processing. Again, you can add access memory to it. You can add access IO modules to it. Okay, so these are the main requirements of industry that it handles. Okay, that is why PLC is so much common in industrial automation. Okay, so we were here. Now I think you understood that this 24 volt is converted or isolated from this signal. Okay, so if there is a fluctuation in 24 volt DC or 24 volt DC in input module or output module, there will always be a isolation from it. Okay, so this CPU or this chip of CPU or this board of CPU will always be isolated from the external environment, and that will be isolated through optical isolator. So it was good from safety perspective also. Yeah, so we learned about power supply. A power supply, SMPS, you can also say. We have already covered that what is the difference between SMPS and power supply. We can use either of them. On the main purpose is to convert AC to DC. Okay, so it converts 220 volt AC supply into 24 DC. Input module works on 24 volt DC. Okay, and converts 24 volt DC supply into 5 volt with optical isolation. Okay, we have already covered this. So input module also do the multiplexing. Okay, so it can also multiplex as multiple input signals are coming from the field, and then sending the data directly towards the CPU. Okay, so your input module is saying that it is consisting of your PII card also. Your CPU module, again the central processor with ROM and RAM. You know this, what is ROM, what is RAM. Okay, so all kind of technology associated to your CPU is there in your CPU module. And you have output module, again PIQ and output module. Okay, so your output module works on 24 volt DC and converts 5 DC supply from CPU to 24 volt DC with the help of optical isolation again. Okay, so the output module also do the demultiplexing. So now here it is saying about PIQ that it does demultiplexing parallel to serial, and it provides a particular demultiplex data and then send it to the respective field output. Okay, so for parallel computing, you can say that your output module is capable of converting your data that has came from CPU, checking the address to which machine this particular output is concerned to, and send it to that output. Okay, and as from output module we get 24 volt DC, DC signal. That means that we can control 24 volt DC operated machines only. Okay, so to make it flexible, control element is required, but with the combination of proper relays and contactors, we can convert this 24 volt into any kind of supply that we want, even 3-phase, 2-phase, any kind of supply, 220 volt or 440 volt, but through relays and contactors. Okay, so what about PLC and CPU memory? Okay, just introspect within yourself that what can be the PLC or CPU memory. So it is your CPU has a load memory where you can see there are two kind of memories which are concerned to your load memory. Uh, so this is your non-volatile kind of storage. Okay, so it can be internal also, it can be external also. Okay, so when there is no this card which is specially available for Siemens PLC. If this card is not available, then your load memory will be internal, but you can also have a external memory. In this load memory, all your programs or those logical programs that you have created will be installed or will be embedded. So your load memory contains your programs. Okay, now you can say about your work memory. So this is a volatile kind of storage. This is a non-volatile because when power supply is gone, your programs will be sustained. Okay, but your work memory, now your CPU cannot call your CPU cannot call directly these programs from the load memory. It needs a particular work memory, just like you have a RAM where your CPU calls the particular, you can say, program through RAM. Here we call it work memory. So work memory is basically your RAM only. Okay, so it is a volatile kind of storage. The CPU copies some element of the project from the load memory into the work memory. First, it will copy from load memory to work memory, and then it will process it. Okay, the program only run in work memory and system memory. It will not work in load memory. Okay, then we have system memory. So all the addressing, all the counters, all the timers, the data associated to this, because every kind of input will have a certain kind of address. You might have seen written in this in many industries. We have also covered it into, let me just show you that image if I have of addressing. uh, I had this addressing. Let me just go to the, yeah, you can see that, yeah, here. So you can see here these addresses are given to a specific input and output. So 0.0, 0.1, been given to your PLC. Okay, so these PLCs addressing, and you can say that data associated to timers, data associated to your counters is called your system memory. Where were we? We were at PLC. Yes, here. Yeah, this is your system memory. Okay, and we have a special kind of non-volatile memory available with Siemens only. Okay, this is called your NVRAM, which is a programmable, and it has a capability to save retentive data. So most of the time what happens is that in your work memory, the data is not retentive. Okay, but this data which is retentive, it can be retentive. A few of the data are non-retentive, which cannot be retentive. Okay, but some kind of data can be retentive, and that can be saved in your NVRAM. Okay, so when your power supply goes, it can happen that the stage, or you can say the stage at that instant of time, will not be saved, but through NVRAM we can also save that. Okay, so just let us have a very simple questionnaire associated to these memories. Okay, now my question to all of you is that where is all the program data is saved? So you have made a program and you have loaded it into your PLC. It will be saved in which kind of memory? Yes. Yes. Okay. Now CPU need to use this particular program. So it will use this particular program from load memory, or it will transfer that program into work memory. So will it work directly through load or it will work from work memory? Yeah, it will first transfer it to work memory. Okay. Your addressing will be associated to which kind of memory? Your addressing, yes, your addressing will be associated to system. Yes, very correct. Yes, correct. Will be associated to system memory. Now my question is that your timers and counters, those data will be associated to, your timers and counters will be associated to which kind of memory? The data associated with timers and counter that will be saved in system. Yeah. So your program that you have installed, is it a volatile memory or non-volatile memory? Your program that you have made and installed, the program that you have made and installed, how can it be a volatile memory? Once you have installed it into a, so where you load a particular program, you load it in a load memory. Okay, and load memory is a kind of fixed memory, non-volatile. Okay, when a power goes, if your program is installed, so if you are saying it is volatile memory, just consider the scenario that your PLCs are working on this load memory only. Okay, every time there will be a power cut, your program is gone. Okay, so you need to reinstall the program every time when there is a power cut. No, we don't need it. Okay, so it is a non-volatile kind of memory. Okay, most of you have answered, some of you have answered it volatile, but it is not correct. I think now you got the answer for this. Okay, our CPU works on 24 volts, yes or no? CPU in your PLC. So it works on how many volts? Muskan, very correct. 5 volts. 5 volts. Okay, we get a supply of 24 volt and we convert 24 volt into 5 volt through optocoupler. Okay, okay. Optocoupler, very correct. Very correct. Yes. Just class, just a minute. Yeah, class. Yeah, so yes, optocoupler is required. So let us proceed further. I think you are aligned till now. So what I was talking about earlier, that we have a PII, excuse me, we have a dedicated process image register, which is a special kind of memory. It is not neither the part of load memory, neither work memory, neither your system memory. It is a special kind of memories that are embedded into your PLC, okay, which are your process image register. And this memory register is always in bytes and divided into two subparts, which is your PII and PIQ equal. So Your process image input table, we have talked that what it does, and your process image output table, we have learned that PIR used for storage of all digital input and output state. The CPU has reserved memory areas which are your PII and PIQs. During program execution, the CPU access these memories areas exclusively. ठीक है? Okay, so program execution के वक्त, okay, during that time the CPU accesses these memory areas executed exclusively, okay, and it does not access the digital input and output modules directly, okay. So PIA and PIQ are intermediate between work in interfacing between your input module and output module. So earlier what we have seen that input module can be said that it is directly associated with PII, or your output module is directly associated with your PIQ. Okay, so the advantage of assessing the process image is that CPU has consistent image of process signals for the duration of one program cycle. If a signal state in an output module changes, okay, again I have we are just repeating it. I have already told you that when a signal state of an input module changes while the program is executed because of the change of speed, okay, the signal state in the process image is retained. So that PII and PIQ can retain a particular memory area where they can retain that particular signal, okay, for the use until and unless we can have that particular cycle of operation, okay, and update it again in the next cycle. So this process repeatedly can be converted into a particular cycle. The process of repeatedly scanning an input within a user program ensures a consistent input information. So always there will be a consistent input information that will be available in the form of PII and PIQ. Okay, so what will happen? Your CPU will never be, if there is a function available or if there is a data available, it will process it accordingly. Okay, so you will have a very nice or you can say very good processing speed associated to it. So PII again is your process image input. We have said that it is a memory area in which the state of all digital inputs are stored. It stores it, it stacks it, and it sends or communicates the CPU with this particular data. Again, PIQ is the memory area where all digital outputs are associated. Okay. So again, the PIQ is output to the digital output at the beginning of the cycle, and outputs can be assigned as well as queried, or you can say queued. It is not queried, it is queued in the program. Okay, so they can be assigned or they can be queued into a particular program. Now, what is the PLC scan cycle? Let us have a look. So, as we are told that we have a PII and PIQ associated, we have a CPU associated. Okay, so this can work in a particular cycle. Okay, so that cycle that in which your PLC perform is called your PLC scan cycle. So you can see that from reading input to executing, the spelling is incorrect, to executing program, to diagnostic communication, to upload output, we will have a certain kind of cycle. Now let us first look at the reading input. So PLC copies the status of physical inputs to the PII. Okay, so what it does is that it copies the status of physical input from the PIIs. Okay, then what it does is that it will read the particular input from the PII. Then PLC will execute the instruction. We have seen that we will have a load memory. It will execute these instructions and store the values in various memory areas. Then what will happen? PLC processing, or it will compile the control logic. What it will do is it will call the program that is required. Okay, it will be compiling the control logic and will perform the task required for communication. So now what it will do, it will try to communicate with the machines that whether they are available or not. Okay, so PLC ensures that firmware, program memory, whether they are connected or not. Okay, until and unless there is a proper connection that is been ensured. You know that your computers and laptops also have a facility of self-test and diagnostic. It can diagnose itself that whether there is a issue regarding communication, yes or no. But if you are giving an option of self-test and diagnostic to a PLC, then first it will ensure that whether the communication is there. For example, if a single machine is not communicated, कोई वायर है बेटा जो आपके पीएलसी और कम्युनिकेशन का था वो निकल गया है, तो वो उस टाइम पे एरर दे देगा पहले ही, एग्जीक्यूशन से पहले ही, क्योंकि अगर वो कनेक्टेड नहीं है तो क्या इश्यू होगा? अगर वो कनेक्टेड ही नहीं है तो वो पहले एरर दे देगा कि हाँ ये आपका एक पीआईक्यू के थ्रू जो आउटपुट है वो कनेक्टेड नहीं है, क्योंकि पूरा प्रोग्राम रन करा के उसको आउटपुट देने का कोई मतलब नहीं होता। आप कहेंगे कि माइक्रो सेकंड में होता है तो फिर हम क्यों इतना परेशान हो रहे हैं, लेकिन अगर एक कोई लंबा प्रोसेस है वो पूरी स्कैन साइकिल को कंप्लीट करते हुए आ रहा है तो वो एक टाइम टेकिंग प्रोसेस भी हो सकता है, और उसके बाद अगर वो एरर बताएगा तो दैट इज नॉट गोइंग टू वर्क, तो वो पहले इंश्योर भी कर सकता है। तो वो पहले एग्जीक्यूशन करता है सेल्फ टेस्ट और डायग्नोस्टिक का। जब कम्युनिकेशन पूरा ठीक से हो जाता है, व्हेन देयर इज अ प्रॉपर कम्युनिकेशन एंड इट इज कंफर्म, after executing the whole process, the result value, okay, so what it did was कि उसने PLC PII से इंफॉर्मेशन ली, उसको एग्जीक्यूट किया, उसने कम्युनिकेट किया कि हाँ कनेक्शन ठीक है, उससे जो आउटकम थे अभी सीपीयू में थे, अब वो सीपीयू से PIQ को दे देगा, ठीक है, और PIQ में राइट कर देगा उसको। अब PIQ कम्युनिकेट करेगा आपका आउटपुट मॉड्यूल से, वहां पे मशीन से कम्युनिकेट करेगा जब तक रन कर रहे हैं, और उससे एसोसिएटेड साइकिल को पूरा कंप्लीट करेगा। वही पीएलसी की स्केल साइकिल कंप्लीटली, you can say it works, okay, and it can be approximately 200 millisecond or 500 millisecond scan time, okay. So for 1 bit or byte type it can be 1 millisecond to 3 millisecond. For 1 bit instruction it can be in megahertz, so it is 1 millisecond or 3 millisecond or more than that, but your scan cycle can be of the rate of 100 ms also, okay. So in order to complete that complete cycle it can be of 0.5 seconds also, okay. Is there any doubt till now, class? I completely understand it is a bit theoretical, but it is important for you to understand this concept. Is there any doubt till now, class? No. 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 स्कैन साइकिल का आपको प्रोसेस अभी आप TIA पोर्टल भी यूज करेंगे, ओके, हम TIA पोर्टल भी थोड़ा बहुत देखेंगे और डिटेल में आप वैसे भी इसको पूरा अप्लाई करोगे, लेकिन पीएलसी का परसेप्शन पहले से अभी थोड़ा अलग है, yes or no? Did you got the perception that yet what kind of cycle it was working, या आपको इसको पहले से पता था ये चीज? Did you know about these facts? But because these facts are also important as far as PLC is concerned. Okay. Okay. So if you don't know, then I think it will be interesting for you. Okay. I will also, yeah. So what kind of scan cycle does a PLC work? It is also very important for you to understand. So now let us talk of our Siemens S7 1200 PLC. So first of all, let us talk about Siemens. So Siemens was founded by Werner von Siemens and John and George Halske in October 1847, and Siemens is a German multinational company. Its headquarters is in Munich and the largest industrial manufacturing company in Europe. Okay, and even in India, most of the manufacturing, or you can say automation based equipments are associated to Siemens only. Okay, so the principal division of the company are industry, energy, healthcare, cities, which represent main activities. Today, Siemens is a global leader in the field of industrial automation. Okay, so if you know how to work on a Siemens based PLC, you will be very much compatible with all the industries, because most of the industries use Siemens based PLC. All how Siemens technology work, you will be automatically knowing about others also, other companies also, that how they operate. Okay, because the basic fundamental is same for all the technologies. So your semantic S7 controller is an intelligent choice for compact automation solution in low and middle performance range with integrated communication and technology functions. They are available in standard and fail-safe versions. Okay, so we have, this is your S7 1200. Now you can see that it is AC, DC, and relay. Okay, so this acronym, this is just a case, okay, that what is the type of your PLC. This AC/DC relay means that first one will be your supply. So kind of power supply that it will get is AC. Don't get confused that how can we get a power supply of AC when your PLC works on 24 volt. It will have an integrated or embedded power associated which will convert AC into DC. Okay, then you have DC. This means that your input module will work on DC. Okay, and relay means it is a relay type. Okay, that means that your output module output will be of relay type, so it will be associated as a relay. Okay, so you can have DC DC DC, AC DC relay, AC relay, not relay in input, but in output you can always have a relay or a DC or a AC. Okay, so it comes with, you can see this is a relay type output. Okay, but your this output can be of, you can say the output that will be generated will be 24, but a relay will be associated which can be linked to any type of output. So you will have 14 digital input. So there are 14 digital input, your 10 digital output, and your 2 analog input. Okay, and can be expanded up to 2048 IOs. So you can see that apart from 14 and 10 digital, you can add sorry, 2048 IOs also. Okay, so this is the amount such a compact device can be associated to 2048 IOs. This is a very huge thing to operate. And the communication protocols are Profinet and Industrial Ethernet. Okay, as far as execution speed is concerned, you will have excuse me 0.08 microseconds per instructions associated to it for a bit type of operation, and 1.7 microseconds per instruction for your word type operation, 2.3 microsecond instruction for, so that it is for a bit, it will be 0 or 1. For a word, what it is a combination of bytes. Okay, and floating point will also be of, you can say, decimal type of instructions. Okay, your memory, your work memory is of 100 kilobyte and your load memory is of 4 megabyte. Okay, these are the specifications. You need not to you can say cram these values, but you need to understand that these are the things that you will be looking when you are going to procure a particular PLC. What will be its processing speed? Okay, so let me just tell you that if you are a manager, what is the main question that you need? That I have a process. Okay, now what I need for a process in order to control it? Yes, a PLC is required. Okay, but processing speed, what kind of output or input I need, and do I need bit type instruction? So for bit type instruction, there will be a very simple process, or you can say factory automation, that it will be a matter of only 0 and 1. Yes. Then you can have word type. Okay, you need to measure some parameters, for example, temperature or something, you will use word type. You can have floating type also, you need decimals associated to it. So these type of questions you need to ask yourself, and you need to have these answers also. So the main motive is not to show you that what is the execution speed. You just have a very small basic idea of that why it is necessary and what is the range of operation. So 0.08 microsecond, you know that now this range works in microseconds. Okay, so for example, you have a very complex process where you have thousands of operations in a span of 1 second. So can you use this particular PLC? Can you not use this particular PLC? Those answers will be given through these specifications. So these specifications are important for you to understand also. Okay, work memory, again, it is important that it is of 100 kilobyte. Your load memory will be of 4 megabyte. Okay, and it can also be expandable. So we have seen that your load memory can be expanded by using external cards. You will have your CPU blocks where your DBs, FCs, FB. DBs are data block, FC is your functional chart, FB is your functional blocks, which are your counters, timers. These all will be associated with your CPU blocks, and the maximum number of addressable blocks will be 0 to 65535. Okay. Your hardware will be 3 communication module, 1 signal board, 8 signal modules can be max. So there will be a signal module also which can be attached to it. Okay, so you need to connect it through Ethernet or something else. Okay, so for that you need a signal module also. Although we have a connection here also, we will look into that detail also. But 8 signal modules you can add so that you can add more and more PLCs with it. Okay, so if you want to add one PLC, you have an embedded slot for that. But in order to add more, you can say PLCs associated to it, you can add 8 signal modules which can be added to it. Okay. Temperature range, it is 20 degrees Celsius to 60 degrees Celsius. Okay. Horizontal installation can be available, vertical installation can be available. Relative humidity of maximum 95% can be handled. Programming language, again, ladder logic, FBD, SCL, we have talked about it. So this is the DIN rail. Okay, so it is the metric rail where we used to install this particular hardware for S7 1200. This is for the electrical panel. Let us just look into the electrical panel only. You will have much more information in that particular video only, and I have a specific video for that also. So just let me use yeah.
Have you ever wondered how an automobile assembly line is controlled? In this video, we're going to talk about
So can you confirm whether the video is clear and sound is clear? Kindly respond, class. Yeah. Okay.
controls large or small mechanical processes like an assembly line. That device is called a control panel. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. Think of a control panel like the human body. Inside our bodies, we have vital organs that control and monitor our surroundings. Similarly, a control panel is a metal box which contains important electrical devices that control and monitor a mechanical process electrically. Let's get started. First, let's talk about the enclosure, the metal box that contains all of the electrical devices of the control panel. Enclosures are often aluminum or stainless steel, and the size will vary based on the size of the process. A control panel enclosure can have multiple sections. Each section will have an access door. The size of the enclosure is commonly referred to by the number of doors the enclosure has. Each enclosure will have an electrical safety rating designated by UL, the Underwriters Laboratories, who governs electrical safety. They will also have an IP rating, or NEMA classification, which designates the enclosure to be indoor or outdoor, waterproof or water-resistant, suitable for hazardous conditions, dustproof, or explosion-proof. Now, let's go inside the enclosure and talk about the non-electrical components that make up the control panel. First, let's talk about the back panel of the enclosure. The back panel is a sheet of metal that is mounted on the inside of the enclosure that allows us to drill mounting holes for different devices, which leads us to our next component, DIN rails. A DIN rail is a metal rail with a standard width used for mounting electrical devices inside. The next component inside the control panel is wiring duct. Ducts allow us to route the wires in an organized and efficient way, while also reducing electrical noise between devices. Next, let's get into the electrical components of the control panel. The main circuit breaker is where the power comes into the control panel for all of the devices. This circuit breaker generally has a disconnect on the outside of the panel that allows us to shut off the power. Always remember the top side of the circuit breaker will still have power. The power that comes into the panel can be anywhere from 480 volts to as low as 120 volts. After the power comes into the panel from the main circuit breaker, the power will be run into a surge arrestor. A surge arrestor is a device that protects all of the electrical equipment inside the control panel from electrical surges or overvoltage. An electrical surge can come from a lightning strike or utility power surge. The power can be connected into a transformer that switches the power down in order to power smaller devices. If the incoming power is above 120 volts, a transformer is generally used. If the power is 120 volts, a power supply can be used to step the power down to 24 volts. Now that the control panel has incoming power from the main circuit breaker and power distributed by a transformer or power supply, the different voltages can be wired into terminal blocks for even more routing of power throughout the control panel. A terminal block consists of two terminals that can join two or more wires together. Terminal blocks can be arranged with several other blocks in a strip mounted on a DIN rail to run power from one source to several devices throughout the panel. The final part of the control panel are the devices that control and monitor the mechanical process. Let's talk about the PLC, or Programmable Logic Controller. The PLC is like the brain of the entire process. The PLC will have a CPU where the logic program is stored. It will have associated inputs and outputs, which will help control and monitor the assembly line. Speaking of our terminal blocks, we will have wires running from them to our inputs and outputs. This allows for the actual control of the assembly line. Field devices, such as proximity switches, photo eyes, and other sensors, are set up on the assembly line to give the feedback needed for the PLC to control the operation of the line. The PLC outputs will be wired to a bank of relays that will close an internal contact that will send power out to turn on or off a device on the assembly line. Smaller relays will control devices such as lights or fans, while a bigger relay, called a contactor, is used to control motors. We will also have a network switch located somewhere near the PLC. This will be powered with 24 volts, and it will be the hub for our communication to and from the PLC to network-compatible devices on the assembly line. One of those devices is our human-machine interface, or HMI. An HMI can be mounted locally onto a panel door or in a remote panel located closer to the machinery. The HMI can be a very dynamic tool in assisting the operator in controlling and monitoring the machinery. The PLC will pass signals over the network to the HMI for monitoring, and the HMI can send signals to the PLC for controlling the machinery. Today, we talked about the components of a control panel. Each control panel will have the main power source coming in that is distributed throughout the panel to varying devices for control and monitoring. Control panels will come in different sizes, but they all have similar devices that we talked about today. Want to learn PLC programming in an easy-to-understand format?
So now class, I think that you are now aware of what is your electrical panel consisting of. So can you list few components that were listed on that are installed on your electrical panel? Now can you answer this question? Kindly answer that what are the components that were installed on your electrical panel? Yeah, those are not ducts, those are dim rails, you can say. MCB, relay, PLC, dim rail. Okay. You had your PLC, relay, contactor. Okay. Okay, relay, PLC. Okay. Were the sensors directly connected to PLC or we had something in between? Sensors. So the sensors, no, sensors were, PLC relay. No, they were not directly connected. There was no relay in between the sensor and PLC. I'm not talking about the actuator, or you can say motors and PLC. Between motor and PLC, Khushbu, there were relays, but between sensors and PLC, there was something. You had terminal blocks, right? Kindly class answer, yeah, Muskan is correct. We had terminal blocks. Yeah. So we had terminal blocks in between. Yes, Aparajita, we had terminal blocks. Yes, Ankush, we had terminal blocks in between which were connected here, which were, yeah, correct, Raj, Nandini, correct, Shumam. We had terminal blocks in between. Okay. So now you know that how your power supply was going. Okay. So if, can I supply 440 volt AC to an electrical panel? My question is this: can I supply 440 volts in an electrical panel? Can I provide a supply of? Yes. But PLC needs 24 volts. So what kind of instruments do you require in order to convert 440 volts into 24 volt DC? Rajnandini, not optocoupler. Optocoupler is inside a PLC. I'm just talking about, we will first use transformer and, Manu, not or, and. Your answer is very much correct. We will use transformer to convert from 440 to any 220 or whatever the power supply is suitable for. And when we will use step down transformer to step down the voltage, and then we will use SMPS. Yes, correct, Abhay. Very correct. And after that SMPS, we will get 24 volt supply to PLC, and someone who has answered optocoupler, after 24 volt supplies switch mode power supply. Okay, so SMPS is somewhat that converts your AC into DC. Okay, so if you want to convert 220, so for if you have a 440 volt and your SMPS is converting only 220 volt, then you will use transformer to convert from 440 to 220, and that 220 volt AC supply will be converted through SMPS. So first of all, in SMPS there will be a transformer that will change the you can say voltage. It will provide you of 24 volt, and then there will be a capacitor and associated circuit associated to it that will convert it into DC. Shubham, I think we have covered the difference between a power supply and SMPS also. SMPS is switch mode power supply. Switch mode, almost the same thing like your power supply is. It's switch, not switch. SWITCH, my bad. Yeah, it is switch mode power supply. Similar to, you can say it is very similar to your power supply, and it converts AC into specified DC voltage. Okay, Shubham? Shubham, is your doubt clear now? Yeah. Okay. So why I have used transformer in between? Because most of the SMPS are associated with 220 volts or 240 volts only. Okay, they are not compatible with 440 volt supply. So first you will use a separate transformer. Yes, very correct. Then it will you will use an SMPS. 24 volt will be supplied to your excuse me, what we say, PLC. In your PLC there will be an optocoupler which will provide 5 volts to your what we say CPU. Okay, then you have DIN rails where you install it, and they were talking about HMI. What is an HMI? Can you tell me what is the full form of HMI? In industries you are going to see lots and lots of HMI. They were talking about HMI. Yeah, human machine interface. So your PLC can communicate with your HMIs, where HMI can also give you a specific data. Excuse me, class. My throat is choked because of lot of construction work here. Lot of dust is here around in my lab. That is why there's lot of dust today. So yes, HMI is your human machine interface, where your human can interact with your PLC. It can give a particular command of whether to start a particular motor or whether to stop a particular motor or to start a particular process. So an intermediate, and it was connected with PLC through, your HMI was connected to PLC through a green colored cable, and that green colored cable is called guys, are you there? That green colored cable, do you know the name of that green colored cable? See, let me repeat this part. I think you have skipped this part.
Interface, or HMI. An HMI can be mounted locally onto a panel door or in a remote panel located closer to the machinery. The HMI can be a very dynamic tool in assisting the operator in controlling and monitoring the machinery. The PLC will pass signals over the network to the HMI for monitoring, and the HMI can send signals to the PLC for controlling the machinery. Today, we talked about the components of a control panel.
Okay, he has not answered that question. My bad. So it is connected to that green through that green colored cable, and that is called Profinet. We will look into this also because we need to look at the communication protocols also. So it is connected through your Profinet. Okay. Now you can you answer it? The HMI is connected to your PLC through. Kindly answer it on the chat box. Now you know the answer. Yeah, Profinet. Yeah, this is a kind of your communication protocol that works. Okay. So we have one more video of this electrical panel, a live video available with us. We will just look into that live video also so that you can, because the understanding of electrical panel is somewhat very much important for you as an electronic engineer. Okay, so just have a very
Okay, we get a lot of questions about the basic of electrical control panels, such as what devices and equipment we typically use, how the devices are wired, how to keep the control panel and the cabinet within a normal.
What we can do is, I think this is a time for a break, and that will be too much for you in a single session. So shall we take a break or continue with this particular video? Or we can continue. Okay. Okay. Let us take a break and let us meet at 4